Welcome to our maths class, and today I want us to slightly improve on what we went through about the rates, and this time round we are bringing in to combine the ratios and rates and then the unitary method. You realize that back in chapter 4 we looked at the unitary method and saw that this unitary method, it is the idea of simply finding what the equivalence of 1 unit, and having found the equivalence value of 1 unit, then you'll be able to get any number of units you require by simply multiplying. That is the unitary method. We've come across it. It's not the first time we are saying it. Now, today here, we want to look at it from now the point where we have the rates ratio and the unitary method. How can we put the three together and work out problems? First, let us start. We find that we are talking about 1 unit. Let us look at a few points and see, can we be able to get 1 unit in whichever area we want to find out? Look at this, 8 baseballs costing $200. So when you look at this statement, the total cost for 8 baseballs is what? $200. So when you talk about finding 1 unit, we should ask ourselves that what would be the cost of 1 baseball? The moment you are talking about 1 baseball, then you have already reduced it to 1 unit. So you'll divide here by 8. So 1 baseball will cost 200 divided by 8. You see? Now, the moment you get, that is 200 divided by 8, it will give us something like 25. The moment you get the cost of 1 baseball, now all the other questions that follows you'll be able to answer. For example, what is the cost of 100 balls? It will just be multiply everything by 100 and you get it is $2,500. What is the cost of 5 baseballs? So unitary method. Finding 1 unit is very, very important. Not only this, look at this also. 5 crickets costing a total of 316. We are talking of 4 crickets. Four crickets cost $316. This is the combined cost of 4 crickets. Finding 1 unit will mean the cost of strictly 1 cricket. So that one will require you divide by 4 on either sides. So then the question comes here. What is the best way to approach these questions? So we shall start by understanding unitary method. Now I'll not write this one down, but I'll explain it because we did it previously in chapter 4. We are doing it again today. Unitary method. It involves finding the value of 1 unit, right? Then, using the information of that value of 1 unit to solve the problem. Find the value of 1 unit, then use that information to solve the problem. That is unitary method. Now, when dealing with ratio, again we saw this one when we introduced ratio. When dealing with ratio, this time now we look at what we call part. So we look at 1 part, that is what unitary means in that case. So in dealing with ratios, Unitary here will mean looking for one part of the ratio. One part of the ratio. That is unitary approach. What am I trying to say here? Let us look at the following example. Ratio of motor cars to motorbike is 35 to 2, and there are 6 motorbikes. Now, when they talk about 2, the side of motorbike is where we have 2. The side of motor cars we have 35, but we are talking of how many motorbikes? 6 motorbikes. They are talking of 6 motorbikes. So, the question here will mean this. Look at these 6 motorbikes. What happened? Because we want to find one part. One part of motorbike. We are talking of 6 motorbikes, and the ratio is 35 to 2. So here, we need to divide by what? By 2. Right? So when you divide by 2, then we shall say one part we shall get one part we shall get number of motorbikes. But now, when you look at our ratio, the ratio is saying this, that the ratio of motor cars to motorbike is 35 to 2. And there are how many motorbikes? There are 6, which means 2 parts of the motorbike is equivalent to 6. That is that side. Take note of that very clearly. These 32 to 2, these are 2 parts. It's not one part. It is not one part. 32 to 2. Therefore, we must get what one part is. And one part here will mean we divide by 2. Because 2 parts is how many motorbikes? 6 motorbikes. So we are saying this. To find one part, 2 parts is 6 motorbikes from here, because 35 to 2 and there are 6 motorbikes. We want one part. This one will be 6 divided by what? 2. Because for us to get this one, we also divide by 2. So we find that one part is 6 divided by 2, which will give us what? It will give us 3 motorbikes. 3 motorbikes. Very good. So when you look at this was a larger ratio, but it's not telling us the bikes. It was only telling us a ratio. I told you earlier on that a ratio is given in a simplified way. So when you look at this, don't wonder how 6 motorbike was coming, but we were just trying to tell us the ratio at which we arrived here. We were looking at the number of certain cars, X to 6, was equivalent to that 5 to 2. That's why what made us to arrive at this. But the one part of the second part is simply divide by 2, so it's equivalent to 3 motorbikes. And also, when you are dealing with the rates, remember it's all about unitary method. Find the value of rate per 1 unit. Look at that. Find the value of rate per 1 unit. Let us look at this example again and see how best are we going to apply this rate per 1 unit. Pedro earned a total of $64 for a 4-hour shift at work. Look at that question very carefully. Pedro earned $64 for a 4-hour shift at work. For a 4-hour shift at work. What comes in your mind? Rate per hour. Rate per hour. Rate per unit. So the question here would be, how much does Pedro earn per hour? So we shall say $64 is earned when you work for how many hours? 4 hours. So when you want to find rate per unit, it will be divided by 4 to get 1 hour, and divide this side by 4, and you'll get it is equivalent to what? It's equivalent to 16. So this is $16 for 1 hour, which is equivalent to 16 per hour. So this is rate per unit. So that's why we are saying, when dealing with rates, it is advisable that you first look for what we are calling rate per unit. Once the value of one part has been known, is it hard for you to get the next part? Is it hard for you to get the remaining 2 parts? Is it hard for you to get even 10 parts when you are asked for 10? No. So we are saying, once the value of one part has been known, then you can easily get the value of any part you are asked for or any part you want. And this is done by what? Yes, tell me. How do we get it? If we know the value of one part, how do we get the value of other parts? Yes. This is done by multiplying. Good. It is done by multiplying. So it means if the rate, like this case, we were talking of $16 per hour. So 1 hour, $16. 2 hours, you multiply 16 by 2. 3 hours, multiply 16 by 3. It is done by multiplying. So here the technique of multiplying and dividing values in what we call successive one-step calculation can be applied in the concept of simply converting rates, can be applied simply in the concept of converting rates from given units to different units. It can be applied in the technique of converting rates from given units to different units. Now, let us look at the following. Now, Andy travels in a total of 105 kilometers in 7 identical car trips from home to school. How far would she travel in 11 such car trips? This is reviewing a unitary approach. So we start by first saying 7 trips. Now, 7 car trips is how many kilometers? 105 kilometers. Unitary method will require us to find what distance will be covered by 1 car trip. To get 1 car trip, what happened? Because we want to talk about 1 car trip. It means that we shall divide 7 by what? By 7 to get 1 car trip. It will take total of, When you divide 105 divided by 7, and you'll get this one is 15 kilometers. So we have it that one car trip is 15 kilometers. Then the question is asking us for 11 car trip, surely. Is it a difficult question? Once you have one car trip, can you be able to get the distance for 11 car trip? Yes, 11 car trip, I'll ask, how did you arrive at 11 from one car trip? It means you multiplied here by what? 11. Go to the number, the distance also, multiply by 11, and you'll find that what you have is that 15 multiplied by 11 is 165 kilometers. So we can conclude this question and say, Andy travels a total of 165 kilometers if she uses 11 car trips, 11 identical car trips. That is what she will do. Now, we want to look at solving ratio problems using unitary method. The ratio of apples to oranges is 3 to 5. If there are 18 apples, remember the ratio of apple to oranges. We said the ratio, the order is very important. So we are talking of apples to oranges, 3 to 5. There are 18 apples. How many oranges are there? How many oranges are there? So, when you look at this left-hand side, it is telling us 3 parts. It's telling us 3 parts. If the ratio of 3 to 5 is equivalent to having 18 apples, and this 18 represents how many parts? 3 parts. Then 3 parts is equivalent to 18 apples. If the ratio was not 3, it was 1, how many oranges would we be talking about? So 1 part, which has been found by dividing 3 by 3, it will be equivalent to 18 divided by 3, which is 6 apples. So 1 part is 6 apples. So this case, when we look at this side, this ratio is a ratio given in form of apples to oranges. That is 3 to 5. And that's why we are saying when we talk about simply 3 parts is 18 apples, therefore 1 part will be equivalent to 6 pieces. It will be equivalent to 6 pieces. Now, our question comes. How many oranges do we have? How many oranges do we have? If 1 part is simply 6 pieces. Therefore, we are looking at oranges, and this time the ratio for orange is 5. So we are looking for how many parts? 5 parts. So we have multiplied this one by 5. Therefore, we shall also multiply this by 5. If you do that, you'll find 5 parts is equals to 30 oranges. So in this question, we can agree that there are 30 oranges. Now, it is always good sometimes when you doubt your answer to go back and prove your answer if it's correct or if it's not. Now, we are talking about current number of apples to oranges. Now, leave along the ratio, we shall simplify, is that at the ratio of 3 to 5, the apples are 18 and oranges are 30. Is it true? So, apple A to oranges O is 18 oranges to 30. Find the highest common factor between these two. You find it is 3. So 18 by 3, you get what? 6. And 30 by, sorry, the common factor here is 6. By 6 here is, by 6 is what? 3. And 30 by 6 is 5. So when you simplify, you find that it gives us the true ratio that we are looking for of 3 to 5. So it is very important that here we are using unitary method. We find one part. And that's why we went ahead and found one part represents 6 pieces. That is where we move from. So 5 parts will be multiplied by 5. Now we want to look at solving rate problems using the unitary method. And here a truck uses 4 liters of petrol to travel 36 kilometers. How far will it travel if it uses 70 liters? If it uses 70 liters. Let us start by the approaching this per rate, or what we call rate per unit. So we are interested in number of liters. So we want to talk how long would it go? We are talking of 36. It's actually taking 36 kilometers. It covers 36 kilometers for 4 liters. Because we want to give rate per unit, then we want to find the kilometers per liter. So we shall divide this by 4 and divide this side also by 4, so that you get that it takes 9 kilometers per liter. For 1 liter. Then the question goes on and asks, how far will this truck travel if it uses 70 liters? Now look here. Already we have 9 kilometers for 1 liter. 70 liters is multiplied by 70. And therefore also on the left hand side we multiply by 70. You will find that you will travel how many kilometers? This is 9 times 70 is 630 kilometers for 70 liters. So we are saying that this truck will travel a total of 630 kilometers in case it will be given 70 liters. Now, we want to convert units using unitary method. Conversion of units using unitary method. Melsa works at a local supermarket where she earns a total of $57.6 for a strictly 4-hour shift. How much does she earn in cents per minute? So we have been given what she earns for 4 hours. So to calculate her wage here, we are looking at a total of $57 for 4 hours. So it implies that 1 hour we shall divide by 4 so that we get per hour And when you do that, you'll find that this one will give us 14.4, we are talking of dollars, for 1 hour. Or we call it 14.40 per hour. So this is what we call the rate per unit. The rate per unit. But the question is asking us, how much does she earn in cents per minute? Cents per minute. So I want to bring this to your attention. We have 14.40 per hour. This is dollars. We shall be referring to that as we go on answering this question about the wage. So a continuation. Convert our rate into cents. We know that $1 is equivalent to 100 cents. All right? Therefore, 14.14 dollars will be the same as 14.40 multiplied by 100. This decimal will shift to the right to give us 1,440 cents, which I can just call it 1440C. So if we rewrite this, we can now say we have it in cents. How about the hour side? The hour side, we look at how many minutes makes 1 hour, and how many, in this case, cents makes $1. We have already done that. So for the hour part, it will be 1 hour is equivalent to 60 minutes. Therefore, we can rewrite this rate as 1,440 cents for 60 minutes. But they are asking how many cents per minute? Per minute. So divide this side by 60. Divide also the cents by what? 60. So they choose to divide that. 60 by 60 is 1 minute. 1,440 by 60, you'll get this one giving us 24 cents. Therefore, 24 cents for 1 minute. Melsa earns 24 cents for 1 minute, which rate can be written as 24C per minute. This is the rate we are looking for when we ask ourselves about what she was earning. Take note, we have been able to convert from dollars per hour to now we have cents per minute. Now, Gemma runs 70 meters in strictly 8.4 seconds. If she maintains the same average speed, in what time will she complete or finish a 100-meter race? So this question, we are trying to find the time taken for Gemma to cover 100 meters. But before we go into that, we need to find out the time taken for, let's say, for 1 meter. How much time will be taken? So here we are looking at 70 meters. Let me call it M. She runs 70 meters for 8.4 seconds. How long will she run? How long will she take to cover 1 meter? That means we shall divide by 70. So I find that the rate of running 1 meter is at the rate of 8.4 divided by 70. You can use your calculator to get the value there, so that we get 1 meter is equivalent to how many seconds. So here it is 8.4 divided by 70. Which gives us 0.12 seconds. If you choose to use another different method, maybe I want to show how to divide that. If you took 8.4 divided by 70, we need to remove the decimal part here, multiply here by 10, multiply here by 10, you get it is 84/700. We did the divisibility test, and we can also find the highest common factor if possible. But slowly we can simplify it by maybe going slowly by 4 here is 21, right? And then by 4 here is 175. So by 7 here is 3. By 7 here gives us 2 because of 14. So we are remaining with 3, 35 gives us 5. So we are talking about 3/25. And this one, when you change it into a decimal, you'll find it is that. Because 30 divided 3 by into 5 is 0, 30 into 25 is 1, remainder 5, 50 into 25 is 2. So this is what you get. I'm only illustrating how to simply get there if you don't have a calculator. So now that we know that Gamma can cover 1 meter in 12 seconds, in 0.12 seconds. Gamma can cover 1 meter in 0.12 seconds. Then now, how long would she take to cover 100 meters? How did you arrive at 100 meters? We simply multiplied here by 100. Therefore, multiply also here by 100. And you'll find that 100 meters will be covered for 12 seconds. So she will take 12 seconds to be able to cover a distance of 100 meters. That is strictly if she'll maintain the same average speed. But if she doesn't, the time might go as it increases. Now here, the question reads, the required staff to student ratio is 2 to 15. And we proceed to say if 10 teachers attend the excursion, what is the maximum number of students who can attend? Remember, the original ratio we have is 2 to 15. And we are saying this ratio simply represents how many teachers? It represents 10 teachers. So we are saying 2 parts is 10 teachers. 2 parts is 10 teachers. 2 parts is 10 teachers. When you talk about 1 part will represent, this is by 2, and divide this one by 2, it will actually give us a total value of, I'll call it 5 parts, or say pieces. So if one part is this, then for us to get for the student, the maximum number of students, then we shall say that if one part now is this, then we are looking for how many parts? 15 parts. This one will be, we have multiplied this one by 15, we multiply this one also by 15, so we'll get this one is equivalent to 75 students. So if there are 10 teachers attending, the maximum number of students who can attend is 75. This ratio can be simplified for when you are confirming your answer. Take, for example, 10 to 75. That is the unsimplified ratio. When you simplify it by 5 here is 2, and then simplify here by 5 here, that one gives us 15. So we are looking at this ratio simplified is this. That's why the maximum number of students becomes 75. Now a tap is dripping at the rate of 200 milliliters in every 5 minutes. How much water drips in 13 minutes? How much water drips in 13 minutes? So we are starting with the rate. So because we are talking of minutes, we want to find out how much goes in per minute. So we have 200 ml for 5 minutes. So if we want to talk about per minute, we shall divide by 5 and divide this side by 5, so that we have 200 divided by 5. This one gives us 40 milliliter for 1 minute. Right? That's what we have. Then they are asking us, how about if it was 13 minutes? Because it is unitary, multiply by 13 to get 13 minutes. It will be actually as a result of what quantity. So it will be 40 multiplied by 13. When you work out that, you get it will bring us to the rate of 40 multiplied by 13, and this one will give us 520. So we can say that for this tap, if it drips for 13 minutes, then we shall be having a total of 520 milliliters. We now have other areas where this time now we are looking at conversions of units. We're given other different rates. As we saw earlier, we realized that you can be given units like kilograms per something, kilometers per hour, liters per minute. But this is now actually needed or required to be converted into a different rate. How do we approach such question? So convert the following rates into units given in brackets. We want to convert the following rates into the units given in brackets. And what are these rates? So the question is, convert the following rates into units given. Convert the following rates into units given. And the first unit that we have, I'll want to handle each question at a time as we actually go through various different rates. We have this is a rate, $15 per hour And we have been asked to convert it to cents per minute. Cents per minute. So this is hours and dollars, but we want to convert it into cents per minute. As I told you earlier on, we must know how to convert. That is very important. So using the knowledge of units of conversion, we shall simply say that $1 is equals to 100 cents. And for the other side, when you're talking about 1 hour, is equals to 60 minutes. Therefore, if we may choose to rewrite this, we shall be talking about, we have this $1 is 100 cents. So $15 would be equivalent to 15 multiplied by 100, which is 1,500 cents, is actually the rate for 60 minutes. But now, when you talk about the rate, the second unit should be 1. So we divide this side by 60 to have 1 minute. Divide this side by 60. We are talking of 60. And then you divide this side by 60. That is the same as getting, we have 2. You can use your calculator. That is giving me 25 for 1 minute. If you use your calculator, you'll find we are talking of 1,500 divided by 60. This one will give us 25. So we are talking of 25 cents for 1 minute. Therefore, the new rate in cents per minute is 25 cents per minute. 25 cents per minute. So you should be conversant with how to convert hours into minute and dollars into cents. Another question, we have got 108 kilometers per hour. 108 kilometers per hour. We want to convert this into meters per second. Now, the first thing we ask ourselves, what is the relationship between kilometers and meters? And the relationship here is that 1 kilometer is equals to 1,000 meters. And when you talk about hours and seconds, this is very interesting. 1 hour is equals to 3,600 seconds. So that's where the trick part now is. So we can now move ahead and see. We are talking of 108 kilometers. So to convert this, we shall mean if 1 kilometer is 1,000 meters, how many meters is 108? It will be 108 multiplied by 100. This one will give us meters. And there is for how long? For 1 hour, and 1 hour is 3,600 seconds. So we have this 108 multiplied by 1,000. This is 108,000 meters for 3,600 seconds. We are looking at the rate of meters per second, which means we have to divide by what? 3,600. So we divide this side by 3,600 so that we remain with 1 second. And this side again the same, divide by 3,600. You can take your calculator and see what you'll get. So when you divide this, you get it is 30 meters for 1 second. So finally, we simply agree and say that our new rate will be 30 meters per second. Will be 30 meters per second. If you do not have a calculator here, you can still use fractions and highest common factor to simplify. For example, 108,000 over 3,600. Now already we look at 2 zeros will cancel off. We remain with 1080 over 36. Let us go by I think 9. It's easier. By 9 here, it is 4. By 9 here, okay, this one will give us 1, 2, 0, which is 120. 120 divided by 4 is 30. That's why we have 30 meters per second. Remember the secret again, knowing the conversion when we talk about kilometers and meters and the relationship between hours and seconds. For hours, we converted first into minutes and then into seconds. That's why we have 3,600. Supposing we are to climb up. Let us look at this one again. We have 60 grams per cent. We want to convert this one to kilograms per dollar. This is an interesting one. Kilogram per dollar. Before we proceed with this, let us have the knowledge of handling decimals and fractions easily. So in this case, we need to have the relationship between grams and kilograms, and we know that 1,000 grams makes 1 kilogram, and 100 cents makes $1. Are we all in agreement here? If that is the case now, how many grams, we have how many grams here? 60. How many kilograms are they equivalent to? How many? It will be, we are talking of 60 grams for 1 cent. We shall be required to change things. This is the same as saying divide by 1,000, so that you have 0 point, we have 0.60. That's what we mean. This one now is not grams, but it is kilograms. For cents, it is divided by 100 is 0.01. And this one is what? Dollars. We must remove the decimals, because we cannot say it is 0.06 kilograms per 0.01 dollars. It doesn't work like that. How do we make 0.01 like that? So whatever we shall multiply here should also be multiplied on this other side. Now you realize that with this one there are 2 decimal places, there are 2 decimal places here. So when you multiply this one by 2 by 100, because of this you have 1, 2, you'll have what? 6 kilograms for 1, 2, 1 for $1. Therefore, we can conclude and say this is equivalent to 6 kgs per dollar. So the knowledge here, we were now moving from smaller units to bigger units, like moving from centimeters to meters. But that one required, the other one we've been multiplying, this one requires us to do what? To divide. And that is what we have. We can look at one more. Now, convert 0.5 kilograms per month. 0.5 kilograms per month, and we want to change this into kilograms per year. Now, before we move, the first quantity is in kilograms. The answer is also still asking us in kilograms, so there's no change there. But we have the second part as months, and the other one as years. So what is the relationship between months and years? We say that 12 months is equals to 1 year. So in other words, here we are talking of 0.5 kilograms for 12 months. Rate is simply making sure what you have here is strictly 1. So we are going to work out this and see what we have. If we talk of 12 months is 1 year, and we want to have 1 month. 1 month is equivalent to what fraction of a year? It is 1 over 12 of a year. Now, in fractions, we want to reduce this one to 1. Take note that 1 over 2 divided by 1 over 2 is the same as 1 over 2 times 2 over 1 by 2, 1 by 2, 1, which is equals to 1. You see that? I want you to see what is going to happen to 1 over 12. Because we need to divide by 1 over 12, that side, and come this side again and divide by 1 over 12. I've said the behavior here would be 1 over 12 divided by 1 over 12 is the same as 1 over 12 times 12 over 1, which is 1 year. So we are having a rate of the other side 1 year. This other side, we have 0.5, which is equivalent to 1.5 divided by 1 over 12. This is 1 over 2 multiplied by 12 over 1 by 2, 1 by 2, 6. So this one is becoming 6, and it is in kilograms per what? Per year, which is, I'll just write it that way. Now, the knowledge of fractions, the knowledge of decimals, the knowledge of how to simplify when you are dealing with maybe decimal fraction is very, very necessary at any given point. So we can convert, but we need to be conversant with the units of conversion. How many units is equivalent to a certain particular unit? That's what is very, very important. That's why we had a month here, but we want to convert it to a year. We said 1 month represents a portion of a year. And I've said it is 1 over 12. That's why we had rewritten this to be 0.54, 1 over 12 of a year. All this that we've gone through, and especially when we are touching on these units, it does not only require us to be able to work out or convert or do what, no, but it requires us also to have prior knowledge of units of conversion when we are talking about distance, when we are talking about time, when we are talking about measurement, time, capacity, volume, and things like that. We must have the units of conversion within ourselves. That is the one which will guide us for us to be able to change the rate from 2 different units to another rate of 2 different units. So that is it. That is it for now. And when we come back in our next lesson, we shall now be looking at those questions that involve solving rate problems. Solving rate problems. Thank you.